Hi, I'm Ankit Shah, a PhD student at MIT with Professor Julie Shah in the Interactive Robotics group. My research focuses on developing algorithms for interactive robot training for temporal tasks. So what are these temporal tasks? Consider the task of setting a dinner table. It involves placing multiple different objects in their correct final configuration. There are multiple admissible and inadmissible orders for placing the different objects, and certain objects only need to be placed if certain dishes are being served for dinner. In general, a temporal task involves satisfaction of temporal properties such as guaranteed future completion, reactivity, or ordering between subtasks. These properties are non-Markov in general, and a wide range of temporal tasks can be represented as linear temporal logic formulas. So how do robots learn these temporal tasks? In our problem setting, the expert's intended task is represented by an LTL formula phi star, and the robot maintains a belief over candidate formulas. In my research, we first developed Bayesian specification inference, a Bayesian approach to identifying task specifications conditioned on experts' demonstrations. Next, we developed planning with uncertain specifications, a novel problem formulation for problems where the task specifications are known only as a belief over LTL formulas. The solution to a punch problem allows the robot to trade off between flexibility and risk aversion with respect to any formula within the support of the belief P5. Lastly, we developed an active learning approach inspired by uncertainty sampling to generate task execution whose acceptability is the most uncertain as per the robot's current belief. A label for such task executions provided by the expert would be most informative for the robot. The expert's label and the demonstration are used to compute an online Bayesian update over the robot's beliefs. Results from our simulation experiments indicate that the active approach generates beliefs that are similar in expectation to the ground truth specifications to a higher degree as compared to learning purely from demonstrations or learning with randomly generated queries instead of informative queries. The robot's certainty over the specification, as measured by the entropy of the belief distribution, also decreases rapidly as more training data is provided to the robot. With promising results from the simulation experiments, we are now attempting to repeat this analysis with a user study grounded in the dinner table setting task. Please feel free to reach out to me with any questions that you might have. Thank you.